Usually when we have an acid-base reaction, we don't just dump them together. We have a way of deciding how far along they are in that reaction, or how close they are to actually neutralizing each other and getting to a neutral pH. And so we use a technique called titration in order to do that a lot of the time. So a titration is what we do to determine the concentration of an acid or a base in solution, and we do that by knowing the concentration of one or the other, and then we can figure out the concentration of the other as we add it to the solution and see where it is neutralized. So if you know the concentration of the base, you will add acid to it slowly until, or you put acid in a container, you add the base slowly until it neutralizes, because you know that when you neutralize it, the number of moles of acid has got to equal the number of moles of base, and this is what we call an endpoint. Okay, and that gets back to because 1 times 10 to the minus 7 molar and 1 times 10 to the minus 7 molar is neutral, and so they're going to be at the same concentration at neutralization point. And so a titration looks something like this. You put your acid solution in the Erlenmeyer, and you're going to add some type of indicator. In the case of this one that we're looking at right now, we've probably added phenolphthalein. Fun word. Okay, and phenolphthalein is clear and acid, and it's a really pretty pink when it's base, in the presence of a base. So what we do is we are adding base, and we have an acid solution in the Erlenmeyer, and as we get close to the neutralization or end point, it's going to start to turn pink because we're getting closer to that basic pH. When we get to the basic pH, it's going to turn pink. So somewhere before that was where we were actually neutralizing. All right, and so, but it's like one drop difference, and it turns really bright pink. So because it's a logarithmic relationship, it's not linear. So that allows us to actually calculate the unknown concentration of something. And so this should look somewhat familiar. You've got molarity. All right, so you've got moles of base over volume of base. That's what molarity equals. And you know what from the balanced chemical equation, you know the mole to mole ratio. That gives you moles of acid. And if you know how much you had, okay, so if you get a certain number of moles and you know that you added 10 milliliters, okay, then you can convert that to moles over liters, I should say there, and that'll give you the molarity of the one that you didn't know. So if you didn't know one, but you know the concentration of the other, you can titrate that and find out exactly what that molarity is. So in a word problem, what is the molarity of a hydrochloric acid solution if 22.5 milliliters of a 0.1 molar sodium hydroxide solution are needed to titrate a 25 milliliter sample of acid? Take inventory, okay? Instead of looking at that and all those numbers and words, you take inventory. The volume of your base, your sodium hydroxide, is 22.5 milliliters. The concentration of the base is 0.1 molar, and that's the same thing as 0.1 moles of sodium hydroxide per liter of solution. Okay? The volume of the acid they give you is 25 milliliters. So the only thing you don't know is the concentration of the acid. So if you have the volume of your base, it's in milliliters, it needs to be in liters, okay? So you've got 1 liter over 100 milliliters times 0.1 molar over liters. So you had milliliters canceling, that should be times. And then liters canceling, and then you're going to be left with moles of sodium hydroxide, okay, moles of sodium hydroxide, 0.00225. So then you take your moles of sodium hydroxide and you're going to go back and you're going to look at your balanced chemical equation. 1 mole of HCl plus 1 mole of NaOH gives you 1 mole of water and 1 mole of NaCl. So that one's easy, but still go through the step because you need to remember that you're going from moles of sodium hydroxide using your mole to mole conversion times 1 mole of HCl per 1 mole of sodium hydroxide, and that's going to give you the same number, 0.00225 moles of hydrochloric acid. Then you have to say you've got 0.00225 moles of hydrochloric acid, and the volume was 25 milliliters. So you've got to convert that milliliters to liters, so times 1,000 milliliters in 1 liter. And that's going to leave you, liters. And that's going to leave you with moles of HCl over liters of HCl, which should come out to be 0.0900 molar HCl.